Okay, fifth and final day of this unit. So the first thing I want to do, we are going to need to know the powers of kind of these first handful of numbers. So I just wanted to walk through them so that you guys have them somewhere and can use them as you start working on your exponential equations. Okay, so 2 to the fourth, 2 squared is just 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth would be 64. And 2 to the seventh is 128. Okay, and remember, that's just multiplying 2 every time. Okay, 3 squared, that's 9. 3 to the third is 27. 3 to the fourth is 81. And 3 to the fifth, again, not going to see this very often, but you might, 243. All right, 4 squared is 16. 4 to the third is 64. 4 to the fourth is 256. And 4 to the fifth is 1024. And then our fives, we have 5 squared is 25. 5 to the third is 125. And 5 to the fourth is 625. And finally, our sixes, 6 squared is 36, 6 to the third is 216, and 6 to the fourth is 1296. Okay, now you don't have to have these memorized per se, but you really are going to need to know all of these because what we're going to be doing is we're going to kind of be moving and kind of finding same bases whenever we have powers. And again, we'll look at it in a second. Okay, so the next thing I want to ask you is it possible to write the following numbers using the same base? And if so, write them as a base with an exponent. Okay, now exactly this is why we kind of did this, so we can kind of refresh ourselves with these powers of the numbers. So we look at 36 and 216. So right off the bat, I know that 36 is 6 squared. So then I think, well, is 216, is that a power of 6? And right here I see it is. So I could write this as 6 squared and 6 to the third, okay? Because again, my goal is to have them have the same base. All right, 25 and 125. Well, in my head, I know, I'm like, okay, I know what 25 is. 25 is 5 squared, so is 125 a power of 5? It is. So this would be 5 squared and 5 to the third. Okay, 4 and 8. Some of us kind of in our head, we go, oh yeah, these are powers of 4, but they're not, because 8 is not a power of 4, it's just a multiple. But we do know that 4 is 2 squared and 8 is 2 to the third. Okay, so again, same bases. All right, now we didn't put our powers of 8 down, but again, I can see that 8 and 64, I know that they are powers of 8. And so I told you right here, there's 2 possible ways to do this one, because we could have 8 to the 1 and 8 squared, or these are also, if we notice over here, these are powers of 2. So 8 is 2 to the third. So this could be 2 to the third, and 64 is 2 to the sixth. So this is 2 to the sixth. All right, okay. Now, we look at this next one and we say, ooh, I don't know because I have that fraction and I don't really know how to think about fractions. Well, remember that last class we talked about how we can have negative exponents. And what negative exponents means is it basically gives us that reciprocal of the fraction. So if this helps me kind of think that, okay, this 1/2 could also be written as 2 to the negative 1, right? Because this is 2 to the 1 in the denominator. So if I bring it up and give it a base 2, it would be a negative 1. And then I think, okay, well, is 8 a power of 2? And again, we do know 8 is a power of 2. So this would be 2 to the third and 2 to the negative 1. All right, 4 and 20. So again, I know that 4 and 20, it's a multiple. 20 is a multiple of 4, but are they powers? Well, 4 could be 2 squared, or we could just think about it as 4. And 20, it's not a power of 2, and it's not a power of 4. So this one is not possible. Okay, again, we see 27 in a fraction, 1/9. All right, so I think, okay, 9 and 27, I can kind of go back up here and say, wait, 9 and 27, these are powers of 3. So then how am I going to get that up into the numerator, right? Well, remember we changed the sign. So 27 is that 3 to the third. And then 9, if we moved it up, this is kind of like saying this is 1 over 3 squared. And so if we moved that 3 up to the numerator where we need it, then it would be 3 to the negative 2. All right, and then our last one we're thinking about, okay, 6 and 48. Oh, well, neither one of these are powers, right? So 6 would be just 6 to the 1, right? And then I would be looking like 36 would be that next power. So again, these are like my 4 and my 20. They're multiples of each other, but there's no way, not possible. So there's no way to make them a power of a power. Okay, so moving forward, the reason that we're doing this is that we are going to start solving exponential equations. All right, exponential equations means that your variable is in the exponent. Okay, so we have our, base, and then we have the two bases, right? And then the exponent is where we see kind of like our equation. So the first thing we're going to do is we're going to convert the base to the same base. Right, so that's why we practice this up here, because 2 and 8, we know that the 2 is that common base, so we don't need to change over this, but then we would change this to 2 to the third. And then we use our laws of exponents, right? Because if I have a power to a power, then I multiply the powers. So that's going to distribute that 3 times the x and 3 times the negative 3 to get me the 3x minus 9. Okay, now when you have bases that are the same and you have simplified their exponents, then we know that the exponents must be the same, because if a base to an exponent is equal to the same base to the exponent, then the exponents must be equal. So this is where you're going to kind of cross out that base and you're going to set the exponents equal. Because once the bases are the same, you're going to set the exponents equal, because if x to the a is equal to x to the b, then a and b have to be equal, and then we just solve that equation. Okay, so looking at our first one, we see, hey, this is nice, starting out easy, right? They're already in the same bases. So if this 4 to the 3x minus 3 minus 2x is equal to the 5 to the negative x, then that means my exponents are the same. So I'm going to mark out the bases and write the equation 3 minus 2x is equal to negative x, and then I'm going to just solve. So I'm going to add my 2x to both sides, and then I have 3 is equal to x. So x is equal to 3. That would be the solution to this exponential. All right, so again, I see another one. My bases are already the same here. So I can just cross out the bases, and then I have negative 2a is equal to 2 minus 3a. So I'm going to go ahead and solve this equation now. I'm going to add the 3a to both sides. So I have a is equal to 2. So again, because if the bases are the same, then the exponents have to be the same. All right, now here's our first one where we're having to find the common power. Okay, so I see 3 and I see 81. So I know 3 doesn't simplify anymore, so I want to check, well, is 81 a power of 3? So I go back up to my list up here and I say, okay, yes, 81 is 3 to the 4th. So I can simplify this. I would leave my 3 to the 1 minus 2x, and then I would simplify this to say it's 3 to the 4th. All right, I'm going to cancel out my bases because my bases are the same, so now my exponents must be equal. So I'm going to subtract 1. I have negative 2x is equal to 3, and divide by negative 2. So x is equal to 3 over negative 2. Okay, let's look at a few more examples. So our next example, so again, we see that we do not have common bases here. So that means we have to get common bases. So again, I think about 27 and 9, and I can go back and kind of look at that, the previous one I just did, right? Or up here, where's my 27 and 9, right? So I already know I can get these to be common bases. So I'm going to say, okay, 27, that's a power of 3. So that is 3 to the third raised to the x power. And then 1 over 9, remember, this is like we have 1 over 3 squared. And then remember, I need to bring it up to the numerator, so that would change the sign. Okay, now if I have a power to a power, remember we multiply the exponents. So 3 to the 3x is equal to 3 to the negative 2. So now that my bases are the same, I can cross out the base and I set my exponents equal. So I divide by 3, x is equal to negative 2/3. All right, 25 and 125. So again, we practice that in our warm-up. 25, we could say, is 5 squared. And then we still have it raised to that x to the 4th power. And then 125, that is 5 to the 3rd. And again, it's raised to that x minus 1 power. Now, guys, here's where you have to be really careful, because when we're multiplying these, we have to distribute. Okay, so this is going to be 5 to the 2 times x plus 4 is equal to 5 to the 3 times x minus 1, right? Because this is part of the exponent, so it's 2 terms, so that 2 needs to multiply by both terms. Okay, so now that my bases are the same, I'm going to cross them out. So I'm going to set up that 2 to the x plus 4 is equal to 3 to the x minus 1. Distribute my 2 and distribute my 3. So I have 2x plus 8 is equal to 3x minus 3. Now I subtract my 2x, and I'm going to go ahead and add the 3. So that goes away, and that goes away. So 8 plus 3 is 11 is equal to x. Okay, last example. So again, I think 4 and 64. Now, again, there's 2 ways to do this, because if you remember, we kind of talked about 4 and 64. Go back up here. 4 and 64 are both powers of 2, and 4 and 64 can both be powers of 4. So I'm going to go ahead and just stick with them being a power of 4, since this already is a base 4. So I won't have to change the right side, but I will have to change my left side. Okay, so remember, 1 over 64. That's like saying it's 1 over 4 to the 3rd is equal to 4 to the 2x plus 3. Okay, we've talked about this. If it's in the denominator, to bring it up, we got to change the sign of my exponent. So 4 to the negative 3, and then 4 to the 2x plus 3. All right, so now that my bases match, I cross out the bases, and I have negative 3 is equal to 2x plus 3. And we solve our equation. We subtract the 3. I get negative 6 is equal to 2x. And divide by 2, negative 3 is equal to x. Okay, so the main goal here is that these are kind of the more challenging ones where we have to get the same base. So your first step is identify if the bases are the same. If they are the same, just like our kind of first ones, right? So if the bases are the same, we just cross out the bases and set our exponents equal. But then otherwise, remember, we need to find like bases and then use the laws of exponents to simplify our exponents. And then again, once the bases are the same, we cross out the bases and we set up an equation to solve for our variable. All right, thanks for watching.